Imagine a future where the vastness of space is not just an endless void peppered with distant stars, but a thriving marketplace where cosmic resources redefine the very fabric of our global economy. Picture a time when the glittering trails of asteroids become the veins of a new industrial revolution, holding the potential to catapult human civilization into a new era of prosperity. This isn't the stuff of science fiction. It's a looming reality, and by 2035, the space mining market could explode from today's modest $12.60 billion to a staggering trillions, reshaping industries, economies, even our society itself. The allure of space mining is as old as our fascination with the stars. Yet, only now are we on the brink of turning this dream into reality. The confluence of technological advancements, economic necessity, and visionary entrepreneurship is forging a path toward an unprecedented economic frontier. But what exactly makes this celestial venture so promising, and why could it happen so soon? Currently, our resource-hungry planet is straining under the weight of its needs. Rare earth metals, essential for everything from smartphones to electric vehicles, are becoming increasingly scarce. Yet, just beyond our atmosphere lie millions of asteroids, each a potential treasure trove of precious metals and minerals. In fact, a single asteroid can contain more platinum than has been mined in all of human history. The implications of this are profound. If we can harness even a fraction of these resources, the economic impact would be nothing short of seismic. Technologically, we're closer than ever to making space mining viable. Advances in robotics, AI, and propulsion systems are converging to reduce the cost of space travel and make the extraction of extraterrestrial resources feasible. Companies like SpaceX and Blue Origin are already reducing launch costs, while others, like Deep Space Industries and Planetary Resources, are pioneering the technology to identify and harvest valuable minerals from asteroids. The development of autonomous mining robots capable of operating in the harsh environment of space is underway, promising a future where humans might not even need to leave Earth's surface to reap the benefits of these celestial resources. The economic impact of this nascent industry could be transformative. By tapping into the virtually limitless resources of space, we could alleviate the pressure on Earth's dwindling supplies, stabilize markets for critical materials, and even drive down costs for consumers. Imagine a world where the price of electronics plummets because the rare metals used in them are extracted from asteroids rather than mined from the Earth. The ripple effects across industries could lead to new technologies, more sustainable practices, and ultimately, a more balanced global economy. However, with great opportunities come significant risks. The legal and ethical landscapes of space mining are still largely uncharted. Who owns an asteroid? How do we ensure that space mining does not become a new arena for international conflict? And what about the environmental impact of mining operations in space? These are questions that need answers before the industry can truly take off. Moreover, the technical challenges of mining in zero gravity, dealing with space debris, and ensuring the safe return of materials to Earth are non-trivial and require innovative solutions and international cooperation. Despite these challenges, the potential scenarios for space mining are nothing short of transformative. Envision mining colonies orbiting in the asteroid belt, serving as hubs of industry and innovation. Picture a future where resources flow from space to Earth, fostering a new age of abundance. The companies and nations that lead in space mining may well dictate the economic and geopolitical landscape of the 21st century. This is not merely an opportunity for growth. It's a pivotal moment that could redefine humanity's relationship with the cosmos. As we stand on the precipice of this new industrial age, the prospect of space mining offers not just the promise of untold wealth and resource abundance, but a chance to reimagine our place in the universe. Will we seize this opportunity and unlock the trillions waiting in the stars, or will we let it slip through our fingers? As we look to 2035 and beyond, the choices we make today will determine whether space mining remains a tantalizing dream or becomes the foundation of our future economy. As we peer deeper into the cosmos and contemplate the potential of space mining, one can't help but marvel at the engineering feats required to make this vision a reality. Picture sophisticated space probes, equipped with advanced spectrometers and AI-driven navigation systems, expertly charting the asteroid belt. These machines will identify the most mineral-rich candidates, setting the stage for a new kind of mineral rush. As they orbit these distant rocks, they'll deploy autonomous mining units, robotic pioneers designed to meticulously extract valuable resources while contending with the harsh, unforgiving environment of space. Yet mining these celestial bodies is only the beginning. The establishment of orbital processing stations is essential to refine raw materials before they even reach Earth. These floating factories will utilize solar energy, harnessing the near-limitless power of the sun to fuel their operations. Imagine arrays of solar panels, vast and gleaming, capturing energy to drive the complex chemical processes needed to refine metals in microgravity. This not only reduces the energy costs traditionally associated with mining on Earth, but also minimizes the environmental impact, a crucial consideration in our increasingly eco-conscious world. But what about the economic implications of such a venture? The influx of extraterrestrial resources could destabilize current markets. How does one price a metal when its supply is potentially infinite? This creates a paradox where abundance could lead to devaluation, requiring new economic models and regulatory frameworks to manage. The potential for monopolistic control over space resources is another concern. Could a single corporation, wielding advanced space mining capabilities, exert undue influence over global markets and politics? The race is on to prevent such scenarios, with international treaties and legislation playing catch-up to the rapid pace of technological advancement. Safety and financing are other hurdles that cannot be overlooked. The financial risk of launching a space mining operation is immense, with initial investments running into the billions. Insurers are still grappling with how to underwrite missions that involve unprecedented levels of uncertainty and danger. The specter of orbital debris also looms large. As more entities enter the space race, the risk of collisions increases, threatening not only individual missions, but the sustainability of space as a resource. Could a single mishap trigger a cascade of destruction, reminiscent of the Kessler syndrome, rendering valuable orbital paths unusable for generations? Then there's the question of governance. Who regulates the burgeoning space economy? The Outer Space Treaty, established over half a century ago, offers some guidance, but is ill-equipped to handle the complexities of modern space commerce. New legal frameworks are needed to address ownership rights, environmental protections, and conflict resolution. Without them, the final frontier could become a new battleground, with nations and corporations vying for supremacy in a lawless expanse. Moreover, the development of space mining could have profound geopolitical ramifications. Nations investing in space technology today are positioning themselves as the superpowers of tomorrow. The strategic importance of space cannot be overstated. Control over extraterrestrial resources may translate into geopolitical leverage, influencing everything from trade agreements to military alliances. This potential shift in power dynamics is driving countries to invest heavily in space infrastructure, launching satellites, and developing new technologies to secure their slice of the cosmic pie. The timeline for these developments is accelerating. By the mid-2030s, we could see the first dedicated mining missions deploying to asteroids, with commercial operations potentially underway by the 2040s. As this industry matures, the integration of AI and machine learning will be crucial. These technologies will not only streamline operations, but also predict market trends, optimize logistics, and even foresee potential conflicts, making space mining not just viable but highly efficient. Despite the challenges, the momentum is building. The vision of a space-based economy is no longer a distant dream, but an increasingly tangible reality. With each passing year, the foundations are being laid for a future where Earth's economy is intricately linked with the cosmos. As humanity takes these tentative steps into the universe, the choices we make will shape the destiny of not just our planet, but potentially countless others. Will we use this newfound wealth to foster peace and prosperity, or will the age-old struggles for power and control extend beyond our earthly confines? The answers lie in the stars, waiting for us to reach out and grasp them. As we navigate the intricate web of opportunities and challenges that space mining presents, the role of technology cannot be overstated. The development of autonomous systems will be central, with AI-driven algorithms orchestrating complex operations from Earth to the asteroid belt. These systems will manage everything from trajectory adjustments to resource extraction, minimizing human intervention in hazardous environments. Imagine fleets of mining drones, each equipped with precision instruments capable of identifying and extracting ore with surgical accuracy. These robotic miners, resilient and adaptable, are designed to withstand the extreme conditions of space, from radiation to micrometeor impacts. Yet, the logistical chain from asteroid to Earth is fraught with complexities. Transporting raw materials through the vacuum of space presents a unique set of engineering challenges. Enter the concept of mass drivers, electromagnetic catapults capable of launching payloads to Earth or lunar bases efficiently. These systems, once operational, could revolutionize how we move goods across the solar system, drastically reducing the cost per kilogram. However, the precision required to ensure these materials safely reach their destination necessitates breakthroughs in guidance systems and impact mitigation technologies. The energy demands of such operations are another critical hurdle. Solar power, abundant and continuous in space, will be harnessed through expansive solar farms, but the efficiency of energy conversion and storage remains a technological bottleneck. Advances in photovoltaic materials and energy storage solutions, like superconducting batteries, are essential to support continuous operations. Moreover, the potential for in situ resource utilization, using materials found in space to build and fuel structures, offers a tantalizing path to self-sufficiency, but requires significant innovation in materials science. While the technical challenges are daunting, the financial landscape is equally complex. The capital expenditure required to develop and maintain a space mining operation is astronomical. Venture capital and government grants only form a part of the funding puzzle. New financial instruments and partnerships between public and private sectors are necessary to share risks and rewards. Insurance models must evolve to cover unprecedented variables, from launch failure to asset loss in the vacuum of space. The volatility inherent in space endeavors demands novel risk assessment strategies to attract investment and ensure long-term viability. The looming threat of orbital debris further complicates these ventures. With each new mission, the probability of collisions increases, potentially jeopardizing entire orbits. Active debris removal systems, capable of capturing and redirecting defunct satellites and detritus, are becoming imperative. These technologies will not only safeguard current missions, but also preserve the sustainability of space as a resource. However, their deployment requires international cooperation and funding, highlighting the need for global governance structures. As we grapple with these multifaceted issues, the legal landscape must also evolve. The current frameworks, rooted in the mid-20th century, are ill-equipped to handle the rapid pace of space commercialization. New treaties and agreements must define clear ownership rights for resources extracted in space, preventing conflicts and ensuring equitable access. Environmental protocols will need to be established to mitigate the impact of human activities on celestial bodies, preserving them for future generations. Simultaneously, the geopolitical implications of space mining are profound. The nations and corporations that establish a foothold in space will wield unprecedented influence over global resource distribution. This could lead to new alliances or exacerbate existing tensions, as countries vie for control over these lucrative assets. The strategic positioning of orbital infrastructure, be it processing stations or defense systems, could redefine national security paradigms, prompting a reevaluation of international relations. As we project forward, the timeline for these developments is crucial. Early adopters and pioneers in space mining could gain a significant competitive edge, creating a new class of economic powerhouses. By the 2050s, we could witness the emergence of space-based economies, with industries operating beyond Earth's gravity well. These developments will necessitate a workforce skilled in both terrestrial and extraterrestrial engineering, driving education and innovation in fields yet to be fully realized. In conclusion, the path to a robust space mining industry is fraught with challenges, yet ripe with opportunity. The choices we make now will echo across the cosmos, influencing the trajectory of human civilization. Will we rise to the occasion, crafting a future where space is an integral part of our economic and cultural identity? Or will we falter, allowing the vast potential of the stars to remain untapped? The answers lie not just in technological breakthroughs, but in our willingness to collaborate, innovate, and venture into the unknown with courage and vision. The cosmos awaits, promising a future as boundless as the universe itself. As humanity stands on the precipice of a new era, the dawn of space mining is set to redefine not only our economy, but also our place in the universe. But this leap into the cosmos is not without its hurdles. Among these is the challenge of creating a seamless supply chain that stretches across millions of miles. The concept of orbital infrastructure becomes critical, with space stations acting as hubs for processing and distribution. These stations will facilitate the refining of materials, reducing the mass and cost of transporting them back to Earth. This leap forward will demand breakthroughs in construction techniques, possibly utilizing 3D printing technologies that can harness in situ materials to build structures in zero gravity. In parallel, the financial models underpinning these ventures must evolve rapidly. The enormity of the investments required calls for unprecedented levels of collaboration between governments, private enterprises, and international consortia. Public-private partnerships will be the cornerstone, sharing both the risk and the potential windfall. This era of space exploration could see the birth of entirely new financial instruments, designed to hedge the unique risks associated with extraterrestrial operations, from prolonged mission delays to the unpredictable nature of asteroid composition. The specter of monopolization looms large, with a few key players potentially controlling significant swathes of space resources. This could lead to an economic imbalance where only a handful of corporations dictate terms and prices, akin to terrestrial oil and gas giants. Regulatory bodies must be established, not only to foster fair competition, but also to ensure that space remains a shared domain, accessible to all nations regardless of their economic stature. This will require visionary leadership and diplomacy, forging new treaties that reflect the complexities of space commerce. Safety remains a paramount concern. The harsh environment of space is unforgiving, with radiation levels that could incapacitate electronics and endanger human life. Innovations in protective materials and radiation shielding are non-negotiable for the safety of personnel and equipment. Furthermore, the reliability of launch systems must increase exponentially, with reusable rockets and rapid turnaround times becoming the norm. The cadence of launches will need to be high enough to maintain a steady flow of materials and personnel, yet each mission will require meticulous planning to mitigate the ever-present risk of failure. The geopolitical ramifications of a thriving space mining industry are profound. As nations race to stake their claim in the cosmos, the potential for conflict over territorial rights and resource allocation grows. The strategic placement of orbital assets, whether for mining, communication, or defense, could shift the balance of power on Earth, prompting a redefinition of security policies worldwide. International cooperation will be essential, yet competition may drive innovation and progress, as it has throughout human history. The timeline for these developments is accelerating, with projections indicating that by the mid-21st century, space mining could be a routine operation. The technological maturation required within the next few decades will drive a surge in education and workforce development, with new disciplines emerging at the intersection of aerospace engineering, robotics, and astrobiology. This educational renaissance will be pivotal, equipping the next generation with the skills needed to navigate and thrive in this new frontier. As we delve deeper into this cosmic endeavor, the environmental impact of our activities must not be overlooked. The pristine nature of celestial bodies holds scientific value beyond measure, and it is crucial to balance exploitation with preservation. Environmental guidelines will need to be established, ensuring that our reach into space does not mirror the ecological challenges faced on Earth. This dual focus on exploration and conservation could guide our approach. In this intricate tapestry of challenges and opportunities, one truth emerges: the cosmos demands collaboration. No single entity can navigate the complexities of space mining alone. It is a collective journey, one that will test the boundaries of human ingenuity and cooperation. As we stand on the threshold of this new industrial revolution, the choices we make today will resonate through the ages, shaping a future where space is not just a destination, but an integral component of our civilization's fabric. With our eyes set on the stars, we embark on this odyssey, driven by the promise of a boundless future. Will we rise to the challenge, harnessing the universe's potential for the betterment of all? Or will we allow this opportunity to slip through our grasp, confined by the limitations of our imagination? The universe awaits, ready to reveal its secrets to those bold enough to venture into its vast, uncharted expanse. As we venture further into the realm of space mining, the complexity of the challenges ahead becomes increasingly apparent. One of the foremost concerns is energy. The vast distances and harsh conditions of space necessitate innovative energy solutions. Solar power, while abundant and efficient in the vacuum of space, requires significant advancements in energy storage technologies to ensure a consistent power supply for mining operations. Nuclear propulsion and power generation are also being revisited, promising a more robust and reliable energy source to sustain long-duration missions and heavy-duty machinery. The automated systems that will become the backbone of these operations must be both autonomous and resilient. Robotics will play a pivotal role, tasked with navigating the unpredictable terrain of asteroids and other celestial bodies. These robotic miners must possess advanced AI capabilities to adapt to unforeseen challenges, making real-time decisions without human intervention. The development of such sophisticated systems will demand a synergy between software engineers and roboticists, pushing the boundaries of what current technology can achieve. Insurance frameworks for space ventures will also need to adapt. The unique risks associated with space mining, from equipment failure to catastrophic loss during launch or transit, require bespoke insurance products. These financial instruments must account for the high stakes involved, offering comprehensive coverage that can reassure investors and stakeholders. Insurers will find themselves in uncharted territory, crafting policies that reflect the uncertainties of a nascent industry where traditional risk assessments fall short. Orbital debris presents another formidable obstacle. As the frequency of launches increases, so too does the potential for space junk, which could jeopardize both current and future missions. Active debris removal technologies, along with stringent regulations on spacecraft design and disposal, will be imperative to mitigate this threat. The international community will need to unite in crafting policies that prevent the Kessler syndrome, a cascade of collisions that could render certain orbits unusable. The legal framework governing space activities is similarly pressing. The current treaties lack the specificity required to address the nuances of space mining. Issues of ownership, resource rights, and liability must be revisited, ensuring that the laws keep pace with technological advancements. New agreements must delineate responsibilities and distribute benefits equitably, fostering an environment where innovation thrives under a legal canopy that protects all parties involved. As the industry matures, the logistical chain from space to Earth will become increasingly sophisticated. Space elevators, once considered the stuff of science fiction, are being explored as potential solutions to the high costs of transportation. These structures could revolutionize the way materials are delivered to and from Earth, drastically reducing costs and increasing the volume of goods that can be moved. However, the engineering challenges associated with constructing such a monumental project are immense, requiring materials and designs that can withstand the stresses of both gravity and space. The timeline for these developments is contingent on overcoming these hurdles. While optimistic projections suggest that space mining could become a reality within a few decades, the pace of progress will be determined by the confluence of technological innovation, regulatory adaptation, and economic viability. The road ahead is as much about pioneering new frontiers in science as it is about reshaping the economic landscape to accommodate these breakthroughs. In this pursuit, the role of international collaboration cannot be overstated. As countries and companies vie for a foothold in space, the potential for geopolitical tension increases. Yet, history shows that joint ventures can lead to remarkable achievements, fostering a spirit of cooperation that transcends borders. The International Space Station serves as a testament to what can be accomplished when nations work together towards a common goal. This spirit of collaboration must extend to the realm of space mining, where the stakes are higher and the potential rewards even greater. As we look to the future, the prospect of establishing permanent human settlements in space becomes ever more plausible. These outposts could serve as bases for mining operations, research, and even tourism. The development of life support systems that can sustain human life in such harsh environments is critical, demanding innovations in recycling technologies and closed-loop ecosystems. These settlements could become self-sustaining economies, trading resources and knowledge both within and beyond the confines of Earth's atmosphere. The dawn of space mining is not just an economic opportunity, it is a chance to redefine humanity's relationship with the cosmos. As we extend our reach into the solar system, we must ask ourselves what kind of legacy we wish to leave. Will we be remembered as pioneers who opened the heavens, or as opportunists who exploited them? The choices we make in the coming years will chart the course for generations to come, shaping a future where space is not just the final frontier, but a new beginning for human civilization. As the stars beckon us onward, the path is fraught with challenges, yet illuminated by the promise of discovery. The universe stands before us, an open book waiting to be read, and it is up to us to turn the page. Will we rise to the occasion, crafting a story of exploration and innovation? Or will we allow the opportunity to slip through our fingers, leaving the pages blank? The future of space mining is a tale yet to be written, and its authors are those who dare to dream beyond the horizon. The cosmos awaits, ready to reward those who are bold enough to venture into its depths, unveiling secrets that have remained hidden for eons. The journey is just beginning, and the potential is limitless.